Hello, this course is on matrix algebra. In this upcoming time, I will be telling you about how I'm going to introduce this matrix algebra for the benefit and the upliftment of your knowledge. So the first is on what are the objectives. First is what is a matrix. So remember that it's from basic to semi-advanced and to the advanced level. I will be proceeding. Okay, so all the things will be, it's a completely all inclusive course. So we all will be identifying the special type of matrices and identify when two matrices are equal. Later, similar parts will also be done. So two matrices are similar and equal, they are not the same. When does a matrix, what does a matrix look like? Okay, so matrices are everywhere, which we see like in spreadsheets or different kind of combinations, how people are doing it. So they're formed with respect to rows and columns that we know. Okay, so here we have this stored information and Clyde, Michigan and copper, three types of thing into four quarters. So now values are represented. This is a, always remember that matrix are written into row into column. So how many rows are there? Three rows and four columns. So this is 3 into 4 cross pattern structure. Okay. Next is what's a matrix? Matrix is a rectangular array of elements. The elements can be symbolic expression of numbers and denoted by this. This may not be always rectangular, maybe square as well. Okay. Next. Now if you see this row, this is a row matrix and this is separately a column matrix. So we can call it as, if I just have 1, 2, 3, 5, 6. So how many rows are here? 1 into 5 columns. And here 1, 3, 5, 6, 7. 1, it's a 5 cross 1. Okay, next. Now each matrix has rows and columns, and the basic thing I've already explained. Now this is another formation of a matrix. It's a 3 cross 4 pattern. And if I write that A3, 4, that is third row, fourth column. This position is A2, 2, and that is equal to 10. This is equal to 27. That way. There are some special types of matrices we will be reviewing. That is a row matrix, row vector, column vector, submatrix, square matrix, upper triangular, a lower triangular. This one is important, diagonal matrix. There's an identity, there's a zero, and trigonal matrix and diagonally atomic matrix. Come then one by one. In matrix, we need to know about the vector that has matrix is vector is a matrix that has only one row or one column. And there are two types of vectors. We always remember row and column vectors. So row vectors look like this. This is a simple row structure, only one row and more than one column. And here more than one column but more than one rows. Okay, so this is the formation. Next we can go to a row vector. So it's a kind of perfect example, but it's an example of a row vector with dimension 5. So it's a row into column, 5 columns are here and into 5. So this mentions the dimension of the vector. Okay, the column vector is example in this way. Next is a submatrix. So the submatrices are, for example, if I give another example, 5, 6, 8, 3, 2, 9, 4, and 5. So if I take this, so this is a submatrix. If I take the entire part of this is a submatrix. If I even take this is a submatrix. I take these four is a submatrix. I take this line even, this is a submatrix. This column even, this is also submatrix. So submatrix is if it is 5 cross 5, anything less in any one dimension will form a submatrix. So what is a square matrix? Simply rows equal to columns. The next, here is an example of square matrix which we have, and it has same number of rows and columns, so it's a perfect square. You can find the determinant of this one as well. The upper triangular matrix. So in upper triangular matrix, this lowest part will be 0. So upper triangular means non-zero parts in the upper part. So the lower triangular will be just the opposite of it. So this thing will be in the upside. We can have it in this formation also. So this is the triangle formation. 3, 2, 1. Okay. So lower or upper dependent on exactly where the zeros are placed in opposite way. Zeros above or zeros below. Okay. Next one. Now diagonal matrix. So there is only a diagonal value exists, nothing else. I'll give you an example of this thing. So this is the diagonal value is there, and the rest of the values are 0. So even this value can be non-zero, like a 7. So these are the special cases of a diagonal matrix. What is an identity matrix? One is the, so identity matrix is a diagonal matrix. Okay. Identity matrix is a diagonal matrix itself, but all the entries equal to 1. Okay, by rows and columns. So this is the position A11, this is A22, this is A33, and this is A4. Okay. And what's the zero matrix? All the values are 0. Very easy. Next, what is a tridiagonal matrix? It's a square matrix. First of all, it's a square, like in this case 4, 4. All elements not on the following are 0, the major diagonal. Okay. And the diagonal above the major diagonal and the diagonal below the major diagonal. So this is the thing. So this is the major diagonal here. Now the diagonal above the major diagonal, so this is this, and diagonal below the major diagonal is this. They are not all zeros, but the rest of the values are 0. So you can take it as 7 as well, or you can add some zeros, but not all the zeros are. Okay, so the rest of the values are 0. So this is the tri-diagonal matrix. Next one, non-square matrix. So do non-square matrices have a diagonal entries? Answer is yes. M into N matrices can have in this way. So non-square matrix is this. Okay. Now what are the diagonal entries? So this is the diagonal. That's it. So still, if a non-square matrix has diagonal, answer is yes. Very much they can. Diagonally dominant matrix. So into square matrix diagonally dominant if this Aij summation is greater than all the values into that one column. Let me just show you by this. So this thing, so 15 is higher than these two values, 6 plus 7. Okay, so this is diagonally dominant. Next, in the next case, minus 4, so this will become 4 is greater than equal to 2 or minus of these two, so 4 is greater than equal to 4. So that as a greater or equal, any one of them can satisfy. And in here case, this is the value and this is greater than 6 is greater than 3 plus 2. So this is a diagonally dominant one. Okay, but the diagonal value in each row wise, this will be higher. But remember that this is not column thing, because in this case 6 is not greater than 9. Next, another diagonally dominant matrix is this. In the last example it was with minus, so change it a little bit. So this is will become 15. So 15 is greater than these two, 6 and 9, greater or equal. Then in the other case, this is 4, same, you can see 5.001. Even a 0.001 enhancement is okay. Okay, this is not a diagonally dominant because 25 is okay, but 8 is not, 1 is not. The other two values are higher. Okay, and now we have come to the last few parts. So what are the two matrices are considered equal if we are same, if the number of rows and number of columns are same? So we make it like this: A is here, P is here, so these two are same. So as with respect to correspondence, we can say these two are also equal. Okay, so equality with respect to all values on correspondence. Clear? So that's it for the first one. Now in the advanced videos we will be explaining the rest of the stuff.